Hey everybody, this is Longo, and in this video we are going to cover polar coordinates. So all the graphing you've done up until now, your brain is used to x, y, left, right, up, down. Those are rectangular coordinates that you've learned since probably pre-algebra. Well, now we're going to switch our mind to what's called polar coordinates, which means these coordinates are going to come from the unit circle and a radius. So polar is in the form of radius comma theta, which theta, of course, is your angle measurement. So when you are graphing these, it's not much different than rectangular in terms of your thought process. It's just that this first one, so this first term is 5, that means our radius is 5. So we're just going to be out on this fifth circle. And the angle is 60 degrees, so that means we're going out to the fifth line, or we can follow the angle and just go out 1, 2, 3, 4, 5, out to the fifth circle, and that's it. So it's not that hard to actually graph a polar coordinate. Now, out there are radian grids as well, and there's all sorts of different grids. I mean, it's not restricted to just unit circle coordinates. There are grids out there that go by 10s or 15s. This one, we know that 3 pi over 4 is over here with a reference angle of pi over 4, which means it's 135. So this means we're just going to go to the angle 135, also known as 3 pi over 4, and we are going to go out to the sixth one. So 1, 2, 3, 4, 5, 6. And that's it. You can have negative directions. Now, just like negative means left or down in rectangular, negative means for the radius we go in the opposite direction, or we're running away from that angle. And of course, negative 90 degrees is the same as just graphing negative 90 on a unit circle or anything that we've done before. So negative 90 degrees is the same as 270. It just means we went backwards, or shall we say clockwise 90 degrees. Now the negative 3 part. So negative 90 is down here, but negative 3 means we're running away from that direction. So we're going up 1, 2, 3. Okay, so that's it. You just think about which angle you're on, and then your radius just tells you if it's positive, you go in that direction that many circles, and if it's negative, you go in the opposite direction. Okay, let's spend a little bit of time converting. Now, to convert from polar to rectangular, if you go back to when you first learned about the unit circle is a radius of 1. It's always a radius of 1. So that's why whenever we were working with the unit circle, we had root 2 over 2, comma root 2 over 2, and all that type of stuff. When you're working with converting polar to rectangular, the radius, as you now know, can be more than 1. So whenever we were looking for x in combination with the radius, that's cosine. So the shortcut to finding x is just the cosine of theta is equal to x over r. So our shortcut, x is always equal to r times the cosine of theta. And y is opposite of theta, which is why y is going to be sine theta is equal to y over r, which your shortcut, y is equal to r sine theta. Okay? So when we are converting that, and I will try to show you on a grid, it's not exactly the easiest grid to read, but this is a grid that puts polar and rectangular on the same, and they don't line up nicely. That's the whole point of having two different methods. They don't line up nicely, but I'm going to just show you just in case it helps you understand a little bit. Okay, so if we were looking for x, we know x is going to be equal to r cosine theta. So this is going to be 2 times the cosine of 120 degrees. Now, going to the unit circle, we know that the cosine of 120 degrees is negative 1/2. So this is going to be 2 times a negative 1/2 from the unit circle, which means we have a negative 1. To find y, y is just going to be 2 cosine theta. So that's going to be 2 cosine of 120. And if you go back to the unit circle, the cosine of 120 is root 3 over 2, which means 2 times root 3 over 2 is just root 3. So our rectangular coordinate for this one is -1 comma root 3. So I'm just going to show you in polar that 120, now because this is really weird looking grid, 120 is actually over here. These are going by 15s. So this is 15, 30, 45, 60, 75, 90. Okay, so 120 is over here. So this guy's 120, and we had 2. So 2, 120 would be right about here. Now, if you look at your polar to rectangular conversion, -1 means we're going to the left 1, but we're going up root 3, which is somewhere between 1 and 2, and that's how you can see we landed right on top of that spot. Okay, so I just wanted to show you using this just in case it helps you understand why the polar and the rectangular coordinates are the same. It's just a little bit complicated to visualize both at the same time. Okay, so with that being said, if we were going to do 4 comma 225, we know x is equal to 4 cosine of 225. And the cosine of 225, this is 4 times. Now the cosine of 225 is negative root 2 over 2. So 4 times a negative root 2 over 2 divided by 2 is going to bring us to a negative 2 root 2, comma. And in terms of y, that is equal to 4 sine of 225. From the unit circle, the sine of 225 is also negative root 2 over 2. So that's going to give us, again, negative root 2, or negative 2 root 2 after we multiply 4 times root 2 and divide by 2. All right, so that is how you convert. Now, you do not have to graph those. Again, it was just to show you how they kind of look. But whenever you're asked to convert, make sure you give an exact answer and make sure you just have your unit circle handy. Okay, that's it for this introduction to polar coordinates. This is Longo and I'm out. See you, bye.